Now, Paracelsus didn't say the last word on toxicology, and there are some things that he didn't say. So, for instance, when a poison enters the body, it doesn't just have to enter the body, it has to reach the target organ. So it has to be absorbed into the body, and then it has to build up in the target organ to a lethal level. But at the same time, the body will be trying to excrete that chemical to get it out. So it's not as simple as Paracelsus was saying. So let's take an example from the element mercury. There are many ways you can conceive of mercury getting into a human body. Mercury is a liquid. So one way, you could swallow liquid metallic mercury. And it really won't do you much harm. In the old days, medical thermometers contained mercury in glass. And of course, if you went to the doctor and you said you had a fever, the doctor would give you a thermometer and say, put this under your tongue. And of course, every year there were cases of people who bit a little bit too hard on the thermometer, broke it open, swallowed the mercury. Didn't really do them any harm. And the reason is that mercury really doesn't get absorbed when it's in its liquid metal state. It's a very strange liquid because it's not a wet liquid, and it doesn't absorb into the body. You could also think that as mercury is a liquid, you could put it in a syringe and you could inject it into someone's bloodstream. Now, this is not good. Okay, it's not good for your health to do this, but even if you inject what should be a lethal amount of mercury, it won't kill you because, again, the metallic mercury is not going to be absorbed. Well, what about compounds of mercury? Well, mercurous chloride, HgCl, also known as calomel, is poisonous. You could eat it, and this will cause poisoning. But even more poisonous is mercuric chloride, HgCl2. This is much more toxic, even for the same amount of mercury. And the reason is that mercuric chloride is much more soluble in water than mercurous chloride, and therefore it's absorbed by the body much more rapidly and will therefore reach high concentrations inside the body much faster. Now finally, what about mercury vapor? If you take mercury and you heat it, you boil it, there's going to be mercury vapor in the atmosphere. And this is going to be absorbed very rapidly because if you breathe in mercury vapor into your lungs, it will go straight into the bloodstream. And this is why there's a picture of King Charles II of England on the slide. King Charles II had many hobbies. He was very fond of horse racing. He was very fond of actresses. But he was also interested in chemistry, and apparently he had his own chemistry laboratory in the palace. And one theory about his death, which happened quite suddenly, was that maybe he had an accident in the laboratory while distilling mercury, and he breathed in mercury vapor, and this is what poisoned him. So the route of administration of a particular poison is very effective. As we've said, to be effective, the poison must get into the target organ. And there are various different routes of administration that we can consider. One is oral administration, and this is where the poison goes in through the mouth and down into the stomach, and then it will be absorbed into the body from the digestive tract. Intravenous administration is possible, and this is where the poison is directly injected into the person's bloodstream. Okay, this method of poisoning is typically fast and efficient, and this is the one that is used in those US states where they still have the death penalty. Poisoning can also occur by inhalation. If the poison is in a gas or vapor form, is breathed in to the lungs and then into the bloodstream. Poisons can also be absorbed through the mucous membranes, This, for instance, the lining of the nose. Inside there is a mucous membrane. And poisons can be absorbed through those membranes again, very fast and very efficient. So here we have the human body and digestive system and the lungs. So stuff, food, drink, air comes in through the nose and mouth, and then the gases go down into the lungs, where gases can be then absorbed into the bloodstream. Food and drink then goes down into the stomach and into the intestines for processing and absorption. So of all those things coming into the body, things like fats, proteins and minerals will be absorbed by the body, and other materials may be absorbed with them. And all the waste products will then be expelled from the body. Now you'll notice in the center of this diagram is the liver. And the liver is very important to toxicology. The liver is a huge chemical processing plant in the center of the body. And it is used by the body for detox. Okay, you don't need to go and pay someone money to detox you, because your liver is doing it to you all the time. And one of the things the liver will try to do is any substance that it doesn't think should be there, any substance it doesn't like, it will chemically transform and then try to get it removed. Now let's consider food. What happens to your food? In particular, the proteins in your food. Well, once the food gets into the stomach, chemical action in the stomach will start to break the proteins down into smaller molecules called peptides. Then further down in the intestines, those peptides will be broken down into the constituent amino acids, which will then be absorbed and will then be used by your body to build. Similarly, sugars, saccharides, they will be broken down to simpler sugars, which will then be absorbed, and your body will use them as fuel. Now, we mentioned earlier snake venom. Snake venom is typically complex peptides. Now, snakes, through their fangs, directly inject their venom into the bloodstream. But what if you were to drink snake venom? Well, I have on good authority, this is from one of the scientists at the Red Cross Snake Farm in Bangkok, that it is relatively safe to drink snake venom. And that is because it is a peptide. So when it goes down into the digestive system, those same enzymes that will break up the peptides in your food to amino acids will also act on the snake venom. So it will be simply converted to its harmless amino acid constituents. But, the man said, don't try this, because if you have any cuts or lacerations, for instance inside your throat, then the snake venom can be absorbed directly into the body, avoiding the digestive system, and then you're going to be in trouble. So please don't try that at home. Now, after digestion, all these molecules will go into the bloodstream. So they will enter the bloodstream, and where do they go next? Well, if we look at the way the blood circulates in the body, the blood that goes past the intestines where the absorption takes place then flows to the liver. And as I've said, the liver is your detox factory. So the liver will try and deal with any toxic molecules before they go to the rest of the body. So it's only things that get past the liver which then go to the rest of the body. So the blood will flow back to the heart and then through the arteries to all parts of the body. Now we can see why inhalation of poisons through the lungs is so effective, because blood that flows past the lungs does not then go directly to the liver. Blood that flows past the lungs can then go to the whole body. There's one more defense mechanism that the body has, and that is the blood-brain barrier. The blood-brain barrier is a membrane around the brain, and this will exclude a lot of molecules that may be in the blood from going into the brain. So if you refer back to the case of Lakhvinda Chima, that molecule, that complex toxic molecule from the curry, was paralyzing his whole body, but it wasn't paralyzing his brain. And that's because the blood-brain barrier was physically keeping that molecule out of his brain. Now, xenobiotics, literally, these are molecules that are strange. And we use this term to refer to molecules which are not naturally present in the body. And these molecules may be ones that we are deliberately adding to our body, such as pharmaceuticals. They may be illegal drugs. They may be natural substances such as nicotine or caffeine, which we're deliberately imbibing, but do not naturally exist in the body. Or they may be other substances such as ethanol. And when your body detects that these substances are coming in, it will seek to deal with them in one way or another. For instance, it may accumulate them in particular parts of the body. For instance, elements such as lead or strontium tend to accumulate in the bone structure. Elements such as arsenic or thallium, the body will try and excrete. And one way it gets them out of the body itself, for instance, is by depositing them in the hair and also in the fingernails, where they can't do any harm. Now, for organic molecules, what your body will typically do, and this is done by the liver, is to transform them into other compounds. In particular, it will try and transform them into compounds which are more soluble in water, which are therefore more easily excretable, for instance, via the kidneys. So let's take one of these molecules. Let's take caffeine, which most people take every day. When you ingest some caffeine through coffee or tea or some soft drink, some energy drink, it goes into your bloodstream, it stimulates your brain, which is why you take it, but your liver is trying to get rid of the stuff, and it transforms it. So the caffeine molecule has these 3 methyl groups on those 3 of the nitrogen atoms. It chops those off one by one to make this more soluble compound, and that is excreted. And this is why, if you have a cup of coffee, after a few hours you start to feel sleepy again. It's because your liver has got rid of all the caffeine and it's time for another dose.